Let's run through complete solutions to the first free response question on the 2024 AP Calculus exam. Now, this is a calculator active problem, so make sure you have your calculator handy so you can follow along with me. This problem is all about working with a table of values, which is a classic AP problem type, giving you a word problem, expecting you to interpret in the context of what's going on. This is a great one for us to be practicing, so let's dive in. So in this problem, we are working with a table of values that's giving us the measured temperature of a cup of coffee as it cools. In this first problem, we are asked to approximate C prime of 5. So the instantaneous rate of change of this coffee's temperature function at t equals 5. And we're told to use it using the average rate of change formula over this interval. Okay, well, you don't have to draw a diagram on the exam, and indeed you probably shouldn't because you want to be saving time wherever you can. But since I have you here today, let me just justify why this is going to work out for us. Okay. So I'm supposed to be looking at the interval t equals 3 up to 7. And so I have this portion of the table that's relevant for me here. Okay. So I have one point at t equals 3, and this other point at t equals 7, and the y coordinates are, okay, I have 85 degrees at t equals 3 and 69 degrees Celsius at t equals 7. I want to know what's happening at t equals 5. I'd love to know exactly what the rate of change is, but I don't have enough information. I've only got these 4 data points. So let's say that we are, the curve of our function actually looks something like this. I don't know, making this up, but we have this point on this curve, y equals c of t. It's right there at t equals 5. And I want to know the slope of that tangent line, okay? Because the slope of this tangent line, by definition, is c prime of 5. Well, I can't figure it out, but what I can do is I can use the 2 data points on either side of it to form a secant line and come up with a pretty good approximation. So you can see here if I zoom in, okay, the green secant line I've drawn joining those 2 points is pretty parallel to the true tangent line at t equals 5. So if I can calculate the slope of that secant line using rise over run, that'll give me a good approximation, hopefully, of what c prime of 5, the slope of the tangent line, is. So that's all we're going to do to get full credit for this problem. So we're going to say c prime of 5 is roughly equal to just the rise over run formula. So c of 7 minus c of 3 all over 7 minus 3. If I substitute in, c of 7 is 69. I'm subtracting 85. That's going to be all over 4. I could just leave it here. The AP isn't testing us on basic arithmetic, but we may as well simplify this to be negative 4. We were told to include units. Okay, so if we look at the quotient that we set up, okay, the numerator is measured in degrees Celsius. That's what they told us. The denominator is time. That's measured in minutes. So our units are going to be degrees Celsius per minute. Okay, so we're done. That's all we had to do here. How were the points divvied up? Well, I got 1 point for showing our work. So we wanted to have something like a rise over run formula appearing there. So we got 1 point for that. And we got 1 point for our final answer. Whether or not we went all the way there to negative 4 or left it as the non-simplified fraction, that's okay. But to get that point, we did need to have those units. It told us to. Okay, good job. So in part B, we are asked to use a Riemann sum to approximate a definite integral. That's a standard task for us. And then we're also asked, sort of as an afterthought, to interpret this quantity here in the context of the problem. We'll get to that, but let's knock out this Riemann sum first of all. So I'm going to draw another diagram, another graph. You don't have to on the exam. And indeed, after we've worked with the graph, I'll show you how we can just work immediately with what we see in the table. Okay. So I have these 4 data points. So I have t equals 0, giving me a temperature of 100. Okay, so literally at t equals 0, the coffee is sitting there just bubbling, boiling away at the boiling point of water. That's too hot for coffee, but we're letting it cool, I guess. That's the whole point of the problem. So then at t equals 3, I have a point at 85. At t equals 7, I have a point at 69 degrees. And then at t equals 12, I have t equals 55. So again, I don't know exactly what this function is due, what this graph looks like, but if I sort of make my best approximation, maybe it looks something like this. Okay, who knows? The important thing is, I know this definite integral is trying to calculate the area under this graph. Okay, that is by definition what the definite integral equals. So between t equals 0 and t equals 12. So a Riemann sum is just going to approximate that area using rectangles. It's that simple. Okay. So let's draw out these rectangles. So I have these bases given to me by the t values of my data point. So that has base 3. 3 up to 7 is 4, and 7 up to 12 is 5. Those are going to give me the bases of my rectangles. And then importantly, notice we were told we're working with a left Riemann sum. So to figure out the height of each rectangle, I'm going to use the left-hand endpoint of each base. Okay. So when I draw up this rectangle, I need to decide, am I going to finish at this height or at this height? Well, the left Riemann sum wants me to go all the way up to that left-hand height. So I get my first rectangle there. I'll draw my next rectangle going up to the left-hand height, and my final rectangle here going up to, again, the left-hand endpoint. So I have these 3 rectangles, and if I can figure out those areas and add them together, that will give me my Riemann sum approximation of this definite integral. That's all we're doing. So the integral from 0 up to 12 of c of t dt is roughly equal to the sum of these 3 rectangular areas. So my first one has a base of 3 times the height is 100. My second area has a base of 4 and a height of 85. And my third area has a base of 5 and a height of 69. Now, we could leave it like this and get full credit, but since I have you here, if you work out what this is, you're going to get 985 as our approximation of this area, of this definite integral. So I said you didn't need to draw the graph, and indeed you don't, because if we see how these numbers compare with our table, well, I have these 3 intervals given to me by the adjacent entries in the table. Okay, so I have my difference of 3, my difference of 4, and my difference of 5. And then all I need to notice is, in those adjacent columns of the table, because I'm looking at a left Riemann sum, the height of my rectangle is the left-hand entry when I look at each pair. So if you are rushing through what the quickest way to get to this Riemann sum approximation, that is how you can do it for basically any table. If there's a right Riemann sum, you'll use the right-hand pair, a partner in each pair, and that's all there is to it. Okay, we were also asked to interpret 1 over 12 times this integral in the context of the problem. Now, what we need to do here is notice this expression looks very similar to a formula that we should have tucked away in the back of our heads, namely the average value of a function on an interval. So if I want to know what the average value of the function f is on some interval a up to b, if I can integrate that function, all I have to do is calculate the definite integral of f from a up to b, and then divide by the length of the interval. So in this case, that would be 1 over b minus a. So if you compare this formula with the expression that they're asking us here, oh, well, this is just the integral of, in this case, c over the interval 0 up to 12, which has length 12. So we're dividing the integral of c from 0 up to 12 by the length of the interval 12. So it's just the average value of that function, the average temperature of the coffee. So 1 over 12 integral 0 up to 12 of c of t dt is the average temperature of the coffee between t equals 0 and t equals 12 minutes. If I was being super precise, I would say, I'm measuring the temperature in degrees Celsius, the time in minutes, but if you look at the scoring guidelines, they actually weren't insisting on you including units here. Okay, let's see, how are the points divvied up here? Well, I get 1 point for attempting the Riemann sum. So if I do something like these 3 areas, these 3 products added together, that's mostly correct, even if it's not entirely correct, I'll get 1 point for the attempt, which is nice. You get 1 point for your answer, whether or not you fully simplified it as 985 or left it as the sum of the products of the constants. You'll get that point. And you get 1 point for this interpretation of the average value function. So that's all there is to it. Let's crack on. Now, we have not needed our calculator yet, but in part C, we absolutely will. Okay. So the table of values is actually going to be done for us, because now what's happening is we're looking at t between 12 and 20. Okay, so the 8 minutes after the table of values told us what was going on, we're now modeling the rate of change of the temperature using this formula here. So C prime, the derivative of the coffee temperature function, is given to me by this formula. And so they simply are asking for me, at the end of those 8 minutes, when t is 20, what is the temperature of the coffee? Well, this is a standard net change problem. Okay. We have the net change theorem, if we want to be fancy about it, but we're going to think about this as the initial value, okay, plus the net change. There are 2 parts to this calculation. Okay. So the initial value is that last data point I observed in the table. Okay. That is just going to be the temperature that I know I measured at t equals 12. So C of 12, which is just 55. And then I need to add on the net change. So what I'm going to do here is I'm going to integrate a rate. Okay. That is what the net change theorem tells us to do. And it's a good thing that we have our calculator, because I don't know how to integrate, let's say, formula for C prime of t. That's the whole point, giving us one we can't do easily by hand. So what am I going to type into my calculator? Well, I'm integrating this rate. So I'm integrating C prime of t from t equals 12, that moment where C prime kicks in, and then I'm integrating up to. So to figure out this value, let's pull up our calculator. Okay, so I'm going to do 55, that initial value at t equals 12, plus the value of this definite integral, which is one of our key calculator skills. Now, if you're a bit rusty on using your calculator, I will put a link in the description and at the end of the video to my 4 essential calculator skills video. It runs through the 4 things that you absolutely need to know before you sit down to take the AP calculus exam. And if you can do those 4 things, you're going to be in a really good shape on the calculator multiple choice and the calculator free response. So check it out if you're needing a little bit of a confidence boost with your calculator. For now, I'm going to assume that we're happy enough with calculating a definite integral. So I pull up the math menu. I hit entry 9 because I want to calculate that integral. And now I'm going to input the parameters. So it's the integral from 12 up to 20. Let's input our rule that they gave us. So it is negative 24.55, whoops, 0.55 times e to the power of 0.01 times the variable. And then I am dividing that by the variable. They use t, I'm using x here. Okay, so I hit enter and what I get is 40.329 if I round to 3 decimal places, which is acceptable. Let's send away my calculator. They haven't asked for units, but I know that I'm measuring in degrees Celsius. Okay. And we're done. First calculator part, knocked out. So how are the points given out here? Well, I got 1 point for knowing that I had to consider the integral of the rate. I got 1 point for remembering to use that initial condition. Okay, the integral just gives me the net change. I need to know what the temperature was at t equals 12. I need to remember to incorporate that into my answer. And I get 1 point for our final answer. Right there. Good work. Good work. Okay, on to the final part of the problem. Here we're still working in that time range, t equals 12 up to 20, those last 8 minutes. But this time they've given me an expression for c double prime, the second derivative. Okay, I could look back at c prime and take its derivative using the quotient rule, but since I have no time, they've given me the expression for c double prime to use in part D. Thank you, AP scorers. Okay, and they're asking us to somehow work out, is the coffee's temperature, is it changing at an increasing rate or a decreasing rate? And we need to justify what our answer is. So let's unpack some of this language a little bit. So we're being asked a question here about the rate of the temperature change. Okay, so the temperature itself is given by the function c. Think back to part A, this table of values, right? That is c of t. The rate of change of c, okay, that we worked with in the later part of the problem, is c prime of t. So what this question is really asking us is c prime increasing or decreasing? So if we repackage this a bit more symbolically, we're asking, is c prime increasing or decreasing? Well, I don't really know. I could try and graph c prime using my calculator, right? I have it. And see if it looks like it's increasing or decreasing. But that might give me the answer, but it won't give me much justification. Because saying I graphed it and it looked like it was increasing isn't going to be sufficient justification on the AP exam. But you'll notice we haven't used this c double prime expression yet. Okay, so what they're hoping we will do here to justify our answer is translate this sentence, this question about c prime, into an equivalent statement about c double prime. So what we can say is C double prime positive or negative, right? And that's just our standard relationship between a function and its derivative. Because if I take C prime and calculate its derivative, I get C double prime. Taking a function, asking if it's increasing or decreasing, like we are about C prime. Taking the derivative, the corresponding question is just asking increasing means the derivative is positive, decreasing means the derivative is negative. Okay. So we are translating this question about C prime into a corresponding question about C double prime. Well, I can graph C double prime and I can convincingly say whether the graph is fully above the horizontal axis or fully below the horizontal axis. That's a justification set that they'll accept from me because I don't need to say, look at the calculator, okay? So let's pull up the calculator and graph this function C double prime. So I'll hit y equals because I want to graph. I'll then input this expression. Okay. So I've got 0.2455 times e to the power of 0.01 times my variable. I'm then, I'm then having 100 minus the variable as a factor, multiplying. Great. I'm then going to divide by the variable squared. So let's see what this function is doing when I graph it. Okay, so that's a bit unexpected, but let's remember, because that doesn't really look like it looks like a vertical asymptote at t equals 0, and that's not the most realistic physical situation you can be in. But remember, we were looking on the time interval t equals 12 up to 20. So this is because I'm looking at the standard window. That's not so relevant for this problem. So let's dive into our window settings and change the x range to be 12 up to 20. Okay. So I can kind of get the sense that it's fully above the x-axis. If I was crunched for time, I would maybe say, oh, this looks like I am getting a C double prime that's always positive, so that means C prime is increasing. Okay. Since I have it here, let's zoom in a little bit. So let's change the window settings. Okay, my y variable now, my y-axis is too wide, too tall. So let's change this to something a bit more constrained. Okay. Okay, so when I zoom in enough, I see that C double prime is definitely always positive on this interval t equals 12 to 20 because the graph is wholly, fully, comfortably above the x-axis. So we're done. Let's just write up our findings. So because C double prime of t is positive on the interval from 12 up to 20, that means that C single prime is increasing. Okay. So in the context of the problem, this would be sufficient to get us the point, but in the context of the problem, what we're really saying is the rate of temperature change is increasing. Just to translate it back into the language of the problem. So here we just got 1 point. Okay, 1 point for the answer together with the justification to do with the sign of C double prime. And that's it. We're done with free response question 1. Nice. So there you have it. We have knocked out the first free response question on the 2024 exam. Halfway done with the calculator section. Good job. As I said earlier, if you need to brush up on your calculator skills, here is a link to my calculator 4 essential skills video that will help you just get super prepared for the AP exam. If you want to work through this 2024 exam the free response questions in order. I'll also put a link to the playlist where I tackle each question one at a time in order. Apart from that, I will just say thank you for sticking with me. I look forward to seeing you in the next video. Bye.